Okay, so we're going to go through the atomic structure exam questions that you did. Okay, so the first question is asking the approximate radius of an atom. So this is our 1 times 10 to the minus 10 metres. B, the figure below shows atoms of 5 elements. The letters are not the symbols of these elements. Complete the sentence. All of the elements in the figure above are in group what of the periodic table? So, two ways in which you could do this. First, you could use your periodic table, even though these aren't the letters that correspond to the letters on the periodic table. You could use the atomic number and see what group those atomic numbers are in. Alternatively, you could quickly work out the electron configuration of the first few. So if you've got 3, inner shell always has 2, and then the next one would be 1, and then just try it with 11 just to check, because you have 2, the next one goes up to 8, and then you're left with 1 at the end. And as you can see, they both have 1 electron in the outer shell, and so they must be in group 1. If you looked at the periodic table, you would have found that lithium, sodium, potassium, they're the 3, 11, 19 that we're familiar with, and so we could have worked it out using that as well. So which 2 atoms in the figure above are isotopes of the same element? So if we remember what isotopes means, that's that they have the same atomic number as they have the same number of protons, as they are the same element. However, they have a different mass number. Due to a different number of neutrons. And so if we then look at our elements above, we've got R and S, both have the same atomic number of 3, but different mass numbers of 6 and 7. So important point, same number of protons, different number of neutrons. The halogens are in group 7 of the periodic table. Explain the trend in reactivity of the halogens. So this is something that we looked at with our periodic table topic, and it's down to our electron shells. But as this is a 6-mark question, then we need to think about the way in which we're structuring this. So when thinking about reactivity, we're thinking about the need to gain 1 electron to form a full outer shell. And they form ions with -1 charge. So our trend, our reactivity decreases down the group. As the electron is less easily gained due to outer shell being further away and so weaker attraction. The other thing we want to do is talk about shielding. Of the inner energy levels. Against the incoming electron. Okay, so for our 6 marks, I'd say we need 3 linked statements. We need to be making sure that we're talking about our energy levels increasing, our distance from the nucleus increasing, and thus making it harder to gain that electron. So, group 7 elements have 7 electrons in their outer shell, and so when they react, they need to gain 1 electron to form a full outer shell. And form -1 ions. Going down group 7, the number of electrons increases, and so there are more shells, and so these shield against the incoming electron, making it harder to gain. Additionally, the outer electrons are further from the nucleus, and so there is a weaker attraction, and so harder to gain the electron. Therefore, going down the group, the halogens become less reactive. Whilst we haven't done about ionic bonding yet, we should still be able to work this out from our knowledge of sodium being in group 1 and our chlorine being in group 7. We know that group 1 metals, they lose 1 electron and form positive ions, whereas our group 7, they gain and form negative ions. Here we lose 1 electron, so we form +1, and here we gain 1, so we form -1. So sodium, and here they call it chloride, as that's the ion, and +1, -1. I'm not expecting us to be able to do parts II or III, as that's to do with a topic we haven't done yet. However, I will just quickly go through these answers just in case you're curious and wanted to know the answer. So when it is solid, sodium chloride will not conduct electricity. However, molten sodium chloride will conduct electricity. Explain this difference. So this is to do with change of state. So as solid, the ions are held in a fixed lattice. Whereas when they're molten, so this means melted down into liquid, those ions then become free to move and so can conduct. As a solid, the ions are in a lattice and unable to move. In molten, they are free to move and so can conduct. Sodium chloride conducts electricity when it is molten and also when it is dissolved in water, because again this allows those ions to be free to move. But again, wasn't expecting us to be able to do those two questions. Here, however, a symbol for calcium atom can be shown like this. What is the mass number of this atom? So here we need to remind ourselves what the difference between mass number and atomic number is. So our atomic number is the one which defines the atom and therefore is our number of protons. Whereas our mass number is the number of particles in our atom which contain mass. So it's our number of protons, because they have a relative atomic mass of 1, and also our number of neutrons, which also have a relative atomic mass of 1, and both of those found in our nucleus of our atom. So our mass number here is going to be the larger one, because you've got protons plus neutrons. So because of that plus neutrons, it's always going to be bigger than the atomic number, as this part here is your atomic number. So our mass number is 40. And what information is given by our mass number? So it's the number of protons and neutrons. Okay, next question is to balance chemical equation. So thinking about our elements on each side. So left hand side, right hand side. We've got 1 and 1, so at the moment they're okay. And here we've got 2 and 1, so this isn't okay. So we need to increase our oxygens on our right hand side. So to do that, we can add a big 2 in front. Remember, we can't change any little numbers, as that would change what the compound is, but we can change the number of those molecules of that compound. So adding a big 2 here, this then means that we have 2 lots of this, but also 2 lots of the calcium atom. So now this is no longer okay, but this is. So now our calcium needs to be increased, so to do that we can add a big 2 in front, and then this becomes a 2, and now it's okay. Describe in terms of electrons what happens to a calcium atom when it becomes a calcium ion. So calcium, if we remember, is group 2. It's a metal, but because it's in group 2, it's going to form a +2 ion, and to do that it must lose 2 electrons. So remember, losing something negative, you become positive. To form a +2 ion, you must have lost 2 negative things in order to gain that. So 2 electrons from calcium's outer shell are lost, and then this leaves it with an empty outer shell, but the shell below it is going to be full, and so it has a full outer shell. Question 3, using the periodic table to help you answer the question, state one similarity and one difference in the electronic structure of the elements from across the period from sodium to argon. So similarity, if they're in the same period, they have the same number of shells. However, our difference, they have a different number of electrons in the outer shell. It increases from sodium to argon. So similarity and difference going down group 7 from fluorine to astatine, again using the periodic table. So our similarity is they all have 7 electrons in the outer shell. Whereas our difference, different number of shells due to increase in number of electrons. Trend in reactivity of group 1 elements. So here we're going from lithium to sodium to potassium, and here we can remember the demonstration I did at the back where we added each of these to water. A little bit of bubbles for our lithium, more vigorous, formed a molten ball for sodium. We even managed to see an orange flame when we did this on the filter paper, and for our potassium we saw a lilac flame and a much more vigorous reaction. So that showed us that our reactivity increases down the group. And then explaining this trend in terms of atomic structure. So this is similar to the 6-mark question we just had in question 1. So our group 1 lose 1 electron to form +1 ions with a full shell. Going down the group, we said how the outer electrons are more shielded and further from the nucleus, therefore there is a weaker attraction and the electron is easier to lose. Just also want to remember to mention the point, I didn't have much space, but that it's due to our extra shielding is due to more energy levels as the atoms get larger. Okay, so here we're having to give reasons why hydrogen could be placed in either group 1 or group 7. So I'm going to start off with why it could be placed in group 1, and that's because it has 1 electron in the outer shell. So hydrogen has 1 electron in its outer shell, and so could be placed in group 1. However, it is a non-metal and so could be placed in group 7. It has a low melting point and low boiling point, whereas we know, like it's a gas at room temperature, whereas we know our group 1 metals are solids at room temperature. They're still relatively low compared to metals, but not in comparison to hydrogen. We also know that hydrogen forms diatomic molecules, which indicates it doesn't have that metallic structure, and I know we haven't looked at structure and bonding yet, but it's already hopefully giving you an indication that there's something different going on there with the hydrogen, where we've drawn it previously as hydrogen molecules. We always see it as H2, whereas our metals we always just see by themselves. So hydrogen forms diatomic molecules, which we've also seen for chlorine and fluorine. Like group 7, and so could be placed in group 7. And then the final thing, hydrogen has a low boiling point and is a gas at room temperature, like the early elements of group 7. And so could be placed in group 7. Okay, question 4. This question is about gold. An atom of gold is represented as 197Au79. How many neutrons are there in this atom of gold? So in a previous question, we said that our atomic number is our number of protons, and is a smaller one because our mass number is our number of protons and our number of neutrons, as both of these particles have mass and are found in our nucleus. But if you look, our mass number is equal to our protons plus our neutrons, and our atomic number is equal to our proton number. So we can rearrange this so that our mass is equal to our atomic number by substituting in plus our number of neutrons, and this is what we're trying to find out. So to find this, we need to subtract our atomic number from our mass number. So we're going to be doing 197 minus 79, so 118. Gold ions are used as a catalyst. Now we haven't talked about catalysts yet, however what we have talked about is how metals become an ion. So it's forming +3, so it must have lost 3 negative electrons. So gold atom loses 3 electrons to form a gold ion. A gold catalyst can be used when carbon monoxide reacts with oxygen to make carbon dioxide. Complete and balance the equation for the reaction. So we're talking about carbon monoxide, which we've got, and oxygen, so adding in our O2 there to make carbon dioxide. So we then need to balance it, so considering our carbon and oxygen on each side of our equation. So we've got 1, 1 at the moment, but oxygen's 1, 2, 3 versus 2. So we're going to need to be increasing our number of oxygens on our right hand side. So if I add a 2 in front of the carbon dioxide, I then end up with 2 carbons here and 4 oxygens here. So now my number of carbons and oxygens on my left hand side are also down by 1. So adding a 2 in front of the CO, that gives us 2 carbons there. We then get 2 oxygens here plus the 2 there, and gives us the 4 that we need for it to be balanced. Not expecting us to be able to do this question as it's part of a topic we haven't done yet. Our talk about gold, again something that we haven't really done, as we need to know more about what a catalyst is here, so don't worry about that question. So I'll just turn over to look at questions for number 5. Okay, so what reaction would take place if the hot tungsten was surrounded by air? Air, of course, is a huge supplier of oxygen, and so we can simply say it would react with oxygen, which is something that we call oxidation, where we're gaining, that metal is gaining oxygen. State why argon, which we know is found in group 8, in the light bulb, explaining your answer in terms of the electronic structure of the argon atom. So group 8 obviously has that full outer shell of 8 electrons. Argon has a full shell of 8 electrons in its outer shell, which makes it very unreactive, as it doesn't need to lose or gain electrons. This part of question 6a, again something that we haven't really talked about. However, we do know that hydrogen ions are positive and therefore are going to be attracted to the negative. So hydrogen ions are positive, and so are attracted to the negative electrode, remembering opposites attract. This next question, however, not expecting us to be able to do, as that's something that we won't look at until next year. But part B, balancing the equation, thinking about our atoms on our left hand side and our right hand side, making sure that they're the same to conserve mass. So far on our left hand side we have 1 lithium, but on our right hand side we have 3. Remember that little 3 applies to the element just before it, unless there are brackets, in which case it applies to everything in the bracket before it. Our nitrogen and 2 and 1 there. So you're going to start off by balancing our nitrogen. So we've got 2 on this side but only 1 on this side. So by putting a big 2 in front, then we change our number of nitrogens, but we also change our number of lithiums. So now we've got 2 lots of the 3, so we have 6. Remember, we can't change the little numbers as they refer to the number of atoms in that particular molecule, but what we can change is the number of those molecules that we have. So now our nitrogens are balanced, we just need to balance our lithium, so we've got 6 this side, we need 6 on our left hand side, and this one's a bit more straightforward, we can just put a 6 in front. Okay, part I, I'm not expecting us to be able to do, but it's to do with this symbol, which you may have seen before, which means that it's reversible, which means that it can go forwards as well as backwards, but again, not expecting you to be able to do that yet. Here, something you might know or we might have talked about is that hydrogen is explosive. As I might have talked about, the Hindenburg disaster back in the 1930s, where just one spark caused the hydrogen gas in the Hindenburg to ignite, all very quickly, very dangerous, and so that's why that method of travel soon ceased. So hydrogen is explosive, but if we're storing it with the lithium nitride, then it's going to be doing this reaction, and so less likely to explode. But if in a tank with lithium nitride, it will react with lithium nitride and so less likely to explode. DI, not expecting us to be able to do. However, our dot and cross diagram. So you complete the diagram to show you the electronic structure of a nitride ion. So they've added the inner shell, they want you to do the outer shell. So 3 minus means it's gaining 3 electrons. So I'm just going to draw in the ones it already had. And then as it's gaining 3, I want to show it's come from something else. So I'm going to use dots to show those additional 3 electrons. They've already added the square brackets and the charge, so you don't need to worry about doing those. And that's all of these questions, so thank you for watching.